Chapter 8, Section 11 in the 7th grade workbook is entitled Symmetry. Symmetry is kind of a fitting end because we've put a lot of topics together here. We've talked about the idea of a reflection, creating mirror images. And we've talked about the idea of congruence, two parts or two shapes being the same. Symmetry is kind of both of those ideas putting together. We're going to, in essence, put a mirror through an image that creates two images that are exactly the same. And that's really what symmetry is. And that's what they're doing in questions 1, 2, and 3. They're asking you to draw a line through the shape that I can create mirror images. Well, if we look at the eye shape in question number 2, that's really easy to do. If I draw a line exactly through the eye, top down or north-south, you see that the left side of the eye here that we have is a mirror image of the right side of the eye. So that would be a line of symmetry. I'm creating two identical pieces. I can also run a line east-west halfway, and I would create mirror images top and bottom. So in two different ways there, I can draw lines that create two identical pieces. So I have two different lines of symmetry, meaning the shape does have line symmetry. So if we go back and look at question number 1 now, obviously I could do the exact same thing there that I showed you in question number 1, the north-south and the east-west to create two mirror images. The top would be the same as the bottom, or the left would be the same as the right. But as I turn the shape now to make similar lines, right, I can see as I turn number 1 a little bit here, I can do the same thing. I can create now north-south lines or east-west lines. And so as you can see, I'm creating a whole bunch of identical pieces. Now, there's other ways to do this as well, which is what makes this particular question even more tricky. If I draw lines from opposite vertices here, opposite corners, which I guess I should do in another color so it'll maybe be easier to see here. If I draw a line from opposite corners, you can see that the pieces are the same here. You've got the tops here, the lefts, the rights, and these bottoms here that are also the same. So you're going to be able to draw a whole bunch of more lines of symmetry as we go through opposite corners here that make the shape have line symmetry, whereas 2 is going to create two identical pieces. So, oh boy, lots of different ways you can draw line symmetry through an octagon. Now in 4, 5, and 6, they're asking you to do the same thing here, but it's different flags of different countries. So in number 4, the flag of Iceland there, where can I, if I even can, draw a line such that I'm going to end up with two identical pieces? Well, if I draw a line north-south like we tried to do in 1 and 2 right away, the problem is I'm going to have this stripe that goes up down on the left side, but I'm not going to have a match here on the right side. So that's not going to be an option. The only way I can have line symmetry here is if I draw a line exactly down the stripe that runs horizontal, left to right. That will then give me two pieces that are the same, the top and the bottom. So that is going to be the only line of symmetry I can draw in question 4. And you'll do the same thing in 5 and 6. Now the bottom set of questions, 7 through 13, is asking about rotational symmetry. Rotational symmetry is me churning a shape. And as I turn the shape, what I want to see happen is whatever's there happens to land back on top of itself. And when it lands back on top of itself before 360 degrees, it has rotational symmetry. It's obviously at 360, it's going to land back on top of itself because that's going to be a full turn. So as I turn number 7, I've got this arrow facing up. Well, as I turn it, eventually what's going to happen is it's going to land here on top of this arrow that's already facing down. And this one that's facing down will be exactly at the same place where this one is that's facing up. And then as I bring it around a full revolution, then it's of course going to land back on top of itself. So here, this shape is going to have 2 times rotational symmetry. Usually what you do is just identify the number of corners here of a shape, and that's going to equal to its rotational symmetry. How you define corner or edge is going to be a little bit up to you, but that's really what we're doing. Here with the spiderweb shape in number 8, as I turn this, since all these pieces are the same, including the star shape that juts out, I see as I go around the star shape, I have 5 kind of corners here, or 5 lines that are jutting out, so there's probably going to be 5 times rotational symmetry. Well, as I turn this and make it land on there, there's going to be 1. As I turn it again and land it there, there's going to be 2. As I turn it again, it'll land on top of that guy, that'll be 3. As I turn it again, it'll land on top of that guy for a 4th time rotational symmetry. And as I turn it for the 5th time, it will land back on top of itself for rotational symmetry. So this shows 5 times of rotational symmetry within one full churn. And then in number 9, this kind of snowflake looking thing, as I churn the snowflakes, eventually what will happen is this snowflake that's on the top here will land where the snowflake is here, so that's 1 time rotational symmetry. As I keep churning it, I'll be able to make it land here for 2 times rotational symmetry, and then as I turn it here, I'll be able to make it land back on top of itself for 3 times rotational symmetry. Realize all this really is a triangle shape here. So when we talk about the corners, like I've talked about previously, we end up with 1, 2, 3 different corners, so in essence you end up with 3 times rotational symmetry. If you're still having a hard time with rotational symmetry, here's an example. I've got a couple different rectangles I'm about to show you here, and they're pink, but that's okay. I'm going to take that one and just lay it down on the paper, and now I'm going to take this other one here in my hand, and I'm going to turn it to make it land on top of itself sometime before 360 degrees. And what I'm going to do is I'm going to put a little mark on it, and I'm going to make that little arrow pointing up. So when I get that arrow pointing up again, that's how I know I've gone 360 degrees. Well, as I start to churn this rectangle, what I see is as I turn this here going down here, there's 1 time it has rotational symmetry because I've been able to make it land back on top of itself. And as I keep churning here, churning, here I am back at the top, but it's obviously landed on top of itself. So how many times does the triangle have rotational symmetry? 2 times, because 2 times I've been able to make it land on top of itself. Once at 180 degrees and a second time at 360. And that's all they're asking you to do. Tell me how many times I can make the shape land on back on top of itself.